Part 3 of section 16.8, and we need to look at another example problem of using Stokes' theorem. Let's see, I'm going to work problem number 8 from the exercises, and we're given the vector field e to the minus xi plus e to the xj plus e to the zk. And we're given that C is the boundary curve to the part of the plane uh, 2x plus y plus 2z equals 2 in the first octant. And the instructions are to evaluate the line integral of f dot dr using Stokes' theorem. And C is oriented counterclockwise as viewed from above. So let's look at this a little bit. So we have the first octant coming out of the page here. Let's see, where's my plane? Let's just quickly plot the intercepts here. If y and z are 0, x is equal to 1. If x and z are 0, y is equal to 2. So see here. And then y and x 0 makes z equal to 1. So all right. So this is our surface S. C is counterclockwise viewed from above. So that means it's going like this. All right, so this is upward orientation. So nothing's, no minus signs to introduce from what we might consider the standard case. Well, let's see. So if we're going to use Stokes' theorem to evaluate this line integral here, then we're going to do so by evaluating the double integral over S. Don't put the vector symbol there. Curl of f dot ds, which is the double integral over this region A in the xy plane of curl of f dot n dA. So let's go through this. Now we already have the simplest type of surface that connects this, or that the curve is a boundary to. So here, there's no sense in thinking about using the independence of surface aspect of Stokes' theorem. So we're just going to directly, as it were, evaluate this double integral here, and curl of f is del cross f. I will let you verify that that's 0, 0, e to the x. Since we are in the special case where z is a function of x and y, you can solve for z here and get that, what is it? Z is 2 minus 2x minus y over 2, or z equals 1 minus x minus 1/2 y. And then upward orientation, when you have z as a function of x and y, the normal vector, recall, is minus z sub x minus z sub y, 1. So in this case, that's minus -1 minus -1/2 is positive 1/2, and then 1. So then curl of f dot n is just equal to e to the x. So we need to compute the double integral over a of e to the x dA. Now this is going to be a dy dx or a dx dy, depending on how we go through the region. Have up at 2, down at 1 here. So it doesn't really matter, because worst case scenario is integration by parts. We can avoid integration by parts if we go through, see, we can take the antiderivative with respect to x first, and then that'll avoid the integration by parts. So we can go, so then we would go from x equal to 0. This is y equals 2 minus 2x, right? So then that's 2x equals 2 minus y, or x equals 1 minus 1/2 y. So I'm going to set this up as the integral from 0 to 2 for y, and then x goes 0 to 1 minus 1/2 y, e to the x dx dy. Okay, so integral 0 to 2. The antiderivative of e to the x is e to the x. And so that's that's the advantage of doing it this way. We don't have to have x's in there. And this is evaluated from 0 to 1 minus 1/2 y. And then that's going to be a y integral with respect to y. Integral 0 to 2 of e to the 1 minus 1/2 y minus e to the 0 dy. This is integral 0 to 2. This is e times e to the minus 1/2 y minus 1 dy. And you've got one more step of integration here. And the only real work to do is with this case right here, equals ... equals 2e minus 4. All right. So there is a lot to remember. There's, a lot of context and what's the normal vector, and so just keep immersing yourself in the material, keep getting familiar with it and feeling more at home, hopefully one problem to the next. Let's see, I think I'll work one more problem from this section in one more video.